Welcome back once again to my channel. If you are new here, thank you for stopping by and welcome. If you haven't yet subscribed to my channel, please hit that red button. In this video, we will answer the question that I uploaded in my previous video, and let us get straight to the point. Here we have a cyclic quadrilateral, and for those of you who may be asking yourself what a quadrilateral is a four-sided figure. It has four vertices, four angles. And when the vertices are standing at a circumference, as in this question, then we refer to it as a cyclic quadrilateral. So we have a cyclic quadrilateral A, B, C, D. And let us also point out some important things. We have a diameter AOD, and if we consider this triangle ACD, we will use a property later on in the video. So we are asked to find the magnitude of this angle X. So the first thing we need to know is a particular property of a cyclic quadrilateral that says opposite angles of a cyclic quadrilateral are supplementary. It means that they add up to 180 degrees. So let us add them. So here we have 125 degrees, and we're adding that to ADC, and they must add up to 180 degrees because they're supplementary. So we get rid of 125 in order to find the value of ADC. We subtract 125 on both sides of the equation, 125 degrees. If I subtract that, ADC is equal to 55 degrees. So now we know that this angle here, 55 degrees. But we need to find this angle X. So we utilize another property. And if you haven't yet viewed my previous videos on circle theorems, the links to those videos are in the description. So if we consider this triangle ACD, angle C is an angle in a semicircle. And we say that the angle in a semicircle is a right angle. So therefore, angle C is right angle, or it's 90 degrees. Then we use another property that says the sum of the angles in a triangle is equal to 180 degrees. So this is what we do. ACD plus CDA plus DAC must give you 180 degrees. So what is ACD? ACD is 90 degrees. CDA, we know that it's 55 degrees, and the DAC is what we need to find, and this must give you 180 degrees. So 90 plus 55 will give us 145 degrees plus DAC equal to 180 degrees. So when you say DAC or CAD, angle A is what we need to find, X. So in order to get rid of 145, we subtract 145 degrees on both sides of the equation. So the result is DAC or CAD is equal to 35 degrees. Very, very easy. So if you haven't yet subscribed, please do so. Subscribe for more videos, because in my upcoming videos I will be focusing specifically on CSEC mathematics topics. Whether you're doing CSEC math, GCSE, all the examinations are similar. And I will be uploading a series of tutorial videos covering a wide range of topics, from transformations, vectors, and so on. Thank you for watching once again. Please share, like, subscribe, and do not be afraid to comment and suggest videos that you wish for me to cover in future videos. Goodbye.